Thank you, Bleach.
Can Daniel do a quick math? Can Daniel do quick math?
Is that a relevant discussion in the sacrificing me or not thing?
You got the 0.67.
All right, the wheel has chosen Samuel, who is actually the last person I just checked and had 7.
One value. One in the class.
Because of course that's intentional.
See, now we're winning.
They're gonna get a couple opportunities for double points. Yeah, because they didn't have an opportunity last month. And they're not going to have an opportunity tomorrow because they have their big Unit 6 organic.
That's not our fault.
All right, so at this time, we're going to go ahead and get started. Let me go ahead and go over the bell work. And then we're going to make a hard stop wherever we're at in the lesson at 8:45. So these lessons have been,
running. I gotta go and catch it.
Stopped at certain points, but if it takes longer, we will have to continue on Thursday. So just a reminder, today you have a team competition in the last 30 minutes of class. Right now, your names are just team 1 through 7, unless you give me a different name. I have everybody's names associated. You will have a different type of competition each time. So today is a team competition. Next class is a mini assessment, which is also a grade. And then when we come back from spring break, you'll have another team competition. And so it'll go back and forth like that. Team competition, mini assessment, team competition, mini assessment, team competition. So with that being said, we are going to get started now at this time for the bell work, the correct order here. And this is a very common question. That's why I wanted to make sure to include one of these on the bell work, is because comparing acidity and basicity is on a lot of the exam. There's almost guaranteed to be either comparing acidity or basicity. Basicity we'll look at on Thursday when we look at amines and amides. All right, so this was C6H5COOH.
Oh, yeah.
C6H5OH. And C6H5CH2OH. That was the order. And then there were many different things you could say for the other 2 marks. This was 1 mark. But you would have wanted to highlight that for benzoic acid, that the C double bond O is an electron withdrawing group. So is an electron withdrawing group. Which weakens the OH bond. And so actually, I think Luke, you didn't get those marks because they needed you to say that. That part had to be there. So not only was it had the electron withdrawing group, but you also have to say whether it weakens the bond or it strengthens the bond. If it weakens the bond, it makes it more reactive, easier to break off, more acidic. If it strengthens the bond, it actually makes it less reactive here, less acidic. And so benzoic acid is an electron withdrawing group. That would be one of the points you could say. And then there were other things you could say. They gave multiple bullet points, and as long as you had said any of these, you would add in a mark for each one. So the next one was to say that phenol has a lone pair of electrons delocalized into the ring, which is delocalized into the ring, and that this also weakens the OH bond, because it pulls the electrons away from the OH bond. So it weakens it, making it more to be an acid. And then the final one with the phenyl methanol, with the CH2OH, that actually had an electron donating group. So the C6H5CH2OH, that part right there, has a CH2 electron donating group that actually strengthens the OH bond. So you could say any 2 of these bullet points out of 3, and that was the other 2 marks, which strengthens the OH bond. So you can say electron donating groups, electron withdrawing groups, but you have to say what that does to the bond energy basically, and whether that ends up making it more reactive or less reactive, whatever type of reaction we're talking about. This, like I said, is a very common question, and I wanted to review with you how Cambridge would word it. Billard 2 is actually another common question. I've seen it on several exams. I had a different one from a different old exam, and I found a newer one. It's about comparing the reactions, so it's related to this last one. It's comparing the reactions of benzoic acid, phenylmethanol, and phenol with sodium, sodium hydroxide, and sodium carbonate. And so this is just making sure you remember those reactions. Benzoic acid reacts with them all. So that would be all check marks. So it's a carboxylic acid, and carboxylic acids react with all three of these. Phenylmethanol is an alcohol. Its main characteristic is that it behaves as an alcohol behaves, not as a benzene. So alcohols only react with sodium. Actually, they don't react with the bases because they are in fact bases themselves. So phenylmethanol would be check XX. And then phenol is actually intermediate, and we didn't explicitly say this last class, but it's in the reactions that you would study that phenol reacts with sodium. Phenol reacts with sodium hydroxide, but there's no reaction card for sodium carbonate with phenol because it doesn't react. Because phenol is not as strong of an acid, and sodium carbonate is a weaker base. And so this would be check X is the idea here. So that was that one. That was 3 marks. Every 3 correct would be 1 mark. So it goes 3, 6, 9, like that. So that's that one. I'll give you a moment.
Yeah.
Last spell work. So benzene 1,3-dicarboxylic acid can be made in a 2-step synthesis as shown below. Name compound P. Most of you got this right. It's called benzoic acid. Benzoic acid. And then it asks, explain why the major product is 1,3, not 1,4. You just had to say here that COOH was an electron withdrawing group, which directs to the 3 position. COOH is an electron withdrawing group. Which directs to the 3 position. Not to the 4 position. So that's all you needed to say there. All right, so that was the bell work review. We've got yet another day of a lot of objectives. Like I said, whatever we got the time for, it's going to be a decent amount of reactions and a mechanism. So remember that there's only 2 mechanisms this unit. So we're doing the second mechanism today. Yes. Put the one what? No, benzoic acid. Okay, so here we go. Looks like a lot. And when we get to organic chemistry, it's always a lot of objectives because most of them are fairly quick. You either know them or you don't. And so today we're going to look at finalizing our reactions of carboxylic acids. We looked at carboxylic acids a lot last year, but this year we're looking at the idea that carboxylic acids can react with the same reagents that alcohols can to change you from a carboxylic acid to an acyl chloride and why that would be preferable. Then we're going to look at carboxylic acids that can be further oxidized, which we actually did in our last lab. Did this in our last lab. Yep. And I'll just remind you of what that was. And then, yeah, our last lab, which was a titration, actually. We did a titration. Describe and explain the relative acidities of chlorine substituted carboxylic acids. We did this last class. We actually did that already. Describe the following reactions with acyl chlorides. So the main thing we're doing today is looking at what acyl chlorides do. First, how to form them, and then what reactions they undergo. Their specific reaction is typically hydrolysis on addition of water to give a carboxylic acid and HCl. The reactions of acyl chlorides are actually very similar to what we saw last unit, esterifications and formation of peptide bonds. It's going to proceed in very much the same way as those types of reactions. And then all of these 5 reactions are all the same type of reaction. Just like a lot of times what you're seeing in this unit is that there's a lot of reactions that are very similar to each other. So as long as you know what to look for, you're going to do the same thing for all 5 of these reactions. Mechanism. We have a mechanism at play today. So we'll be looking at the 2 out of 2 of our mechanisms. And then explain the ease of hydrolysis. So another explanation standard. Those you typically run around 3 or 4 marks. So just a reminder on schedule. I posted this last class. We are, after today, 2 lessons done with content. So just 2 lessons from done with content. Those lessons are going to be on the 18th, which is Wednesday, and on the day we come back from break. Those will be the 2 lesson days. And then after that, you actually have 2 review days built in between to study for the Unit 6 exam, along with competitions and mini assessments. And so your Unit 6 exam is going to be April 8th, which for seniors, you'll know is the day before your grad bash trip. That way you don't have to worry about studying over grad bash. Because we'll be done and you have, like I said, a whole week to review beforehand. So you should be well prepared, well ready for that test. And then there'll be 2 additional review days, one on your own, April 10th, and then one with us together, the 14th. And then you have a full paper 4 mock exam on April 16th, all 100 points. So you'll have to study for that as well. So that's what's going on. Remember, today we've got a competition, and we'll be getting ready to start that at 8:45. So at 8:45 is when you'll start to get into your group. And I'll give you 10 minutes to come up with a group name. Just a reminder of the structure of the competitions, because there were a significant amount of people that were missing last class. Today you have a team competition. If you're in first place on a team competition, your team gets 8 points. If you're second place, you get 6 points. And then if you're at the bottom, you get 1. And for individual contribution to competition, if you score a 93% or higher, which is going to be 14 out of 15 marks, because all of the individual competitions will be 15 points, 15 marks. You get 3 points for each person who does that. 80 to 92 is 2 points. 67 to 79 is 1 point. And if you don't get at least a 67, 0 points. And team 2 has only 3 people instead of 4. So they have a little bit of a handicap, just like I did last year for the team that only had 3 people. Their handicap is they get 1 extra point on team competitions for their extra person. Glenn, right? The name of?
Yeah.
Okay. And then for the individual competition, the average score of the 3 people gives us Glenn's score. So that's our handsome students for the competition.
Watch Glenn be better at organic than me.
We'll find out. We'll find out the results after the mini assessment. I'll let you know.
What's his last name?
Daniel, outdoor, the trumpet's better than you. Outdoor, the trumpet is going to be better than you.
Wow. You know, organic is what it is. Let's go ahead and get started. So, oxidation of methanoic acid. This is just something to remember from the past. If I've got methanoic acid and I oxidize it, so you should write this down. It gives you this, a double carboxylic acid. But this technically is unstable and falls apart. Do you remember what it falls apart to become? Water and carbon dioxide. So this is actually not in the standards until right now. But we have been looking at this for a while. Like I said, we actually did this in our last lab. So be aware that this would decolorize KMNO4. This reaction would decolorize KMNO4. That's what we did in the last lab. The titration we had was with permanganate. And it would turn potassium dichromate from orange to green because it does oxidation. And those are the chemical tests for oxidation. Same thing happens with ethane dioic acid, which some of you might remember is oxalic acid. And this was the exact chemical that we had reacted with KMNO4. We did it last unit, and you may remember this in its other form without the 2 hydrogens as oxalate ion, C2O4 minus 2. Do you remember where that showed up in the standards?
No, en complexes.
Complexes.
The-
It's bidentate. It's a bidentate ligand. And this also does the same thing with KMNO4, where when it gets oxidized, it falls apart to become carbon dioxide and water. And so that's just something for you to be aware of, something that was actually mentioned when we did this at the lab, but it's a standard that Cambridge wants you to know about and be aware of. So it's in the carboxylic acid section, so I just threw it in there. I was supposed to take this out, but just real quick, why is methanoic acid never prepared by refluxing methanol with acidified potassium bichromate? Why don't you keep it as methanoic acid? So if I have methanol, why does it not become this? Lisa,
Maybe because it just keeps oxidizing still, so it
because it oxidizes. Right. That's fine. That's all. That's why I said I was going to take out the question from the textbook because we've done this before, but I forgot to. So that's just what the answer is.
Then how'd you make methanoic acid?
Not that way. So not from methanol. You'd have to, if you start with an acyl chloride, you can make it. If you have an acyl chloride.
couldn't be the same.
What?
Couldn't be the same for some reason.
You might be able to, but the problem is you distill it as an aldehyde before it gets to the carboxylic acid. Once making the carboxylic acid will still become water and dioxide. Okay, so let's talk about acyl chlorides because that's what this whole entire lesson is pretty much about. Acyl chlorides are actually very similar to carboxylic acids, and their reactions are almost carbon copies of reactions you do with carboxylic acid, with one key variant. This bond is weaker than the bond between carbon and oxygen in a carboxylic acid. So this bond right here is a little bit stronger, and this bond is a little bit weaker. Why does that matter? Well, chlorine is a good leaving group. Why does that matter? It makes it more reactive. So acyl chlorides tend to do all of the same things that carboxylic acids do, but they are more reactive than carboxylic acids. So they do them better. And so chemists will often make a carboxylic acid into an acyl chloride to get some other reaction done faster with a higher yield. And so acyl chlorides look a lot like carboxylic acid. Do you remember how to name them? Because we did discuss that before. How would we name them?
Like something so.
They had a weird name. Ethanoyl.
Is that actually it?
Ethanoyl chloride. Acyl chloride has the oil ending. Like it has OYL because the YL is from acyl. So instead of ethanoic, it's ethanoyl, like that. So the ill for the acyl chloride. That would be ethanoyl chloride. And so that's how you'll know you have an acyl chloride. It'll end with ill chloride. So how do you make them? I know you're so excited for these flashcard reactions.
Sure.
They're the same reactions as they were in AS chemistry, except instead of with the carboxylic acid, you can do this, except with an alcohol, you can do this with the carboxylic acid. So if you have a carboxylic acid and use PCl5, you get an acyl chloride, and then you get these byproducts. Is there a chance they can ask you for the byproducts? Yeah. So you can choose to memorize them or not. Your choice. But on the 100 marks, it could be a point. You can use PCl3. If you choose PCl3, you have to say heat is required, whereas for the other two, you do not have to keep those two, PCl5 and SOCl2. And so PCl3 to me is the most complicated one to remember for that reason. And the products aren't that easy to remember as well. And SOCl2 has no special conditions and gives you a really good yield of a pure product because both SO2 and HCl come out as gases. So you're left with simply the acyl chloride in water. And so SOCl2, we said last year, was your best choice for turning alcohols into chlorides. Here we're talking about turning carboxylic acids into acyl chlorides. So last year we used these reactions to do OH to Cl. That's what we did last year. This year, almost the same thing, but it's COOH to COCl. That's the change. Same reagents, same technical thing going on, but instead of alcohols to chlorides, it's carboxylic acids to acyl chlorides. Once you make an acyl chloride, you can do like a Friedel-Crafts acylation. So that would be an interest of having an acyl chloride, because then you can get stuff onto a benzene ring, which Friedel-Crafts can show up on today's competition and on next class's thing. Don't let me forget to give you a practice mini assessment. I did make one yesterday before leaving, a practice one, so you can see what the mini assessments will look like. Okay, let's take a look at the question. Benzoyl chloride. And yes, that's the name of the acyl chloride with benzene. Benzoyl chloride, oil chloride, can be made from methyl benzene in a two-step process, and a reaction scheme is shown. What do you think the intermediate is to go from here to here?
Oh, yeah, that's what it is.
Alexander.
I was gonna say you need like an AlCl3 catalyst.
Nope. That would just put something else on the ring. You need to change the group that's here from CH2CH3 to COCl, but you can't do it in one step. What do you have to get first? Francesca. Oxidize. So step one is to oxidize it with the KMNO4, alkaline. What would you get as a result? Benzoic acid. So benzoic acid is your product of step one. Then your benzoic acid can be changed to COCl afterwards. So then what would the reagent be for step one? I just said it. KMNO4. And conditions. They accepted just hot, and they put alkaline in parentheses. So they accepted hot KMNO4. But it is with OH minus. And then what would be the reagents and conditions for step two? To turn COOH to COCl on the benzene ring.
PCl5, sure.
PCl5 works. What else could it have been? PCl3, but you would have had to also say E or SOCl2. Any of those three. So the next question sometimes trips us up. What is the type of reaction in step one? Oxidation. What is the type of reaction in step two? It's substitution. If you're swapping out the OH for the Cl. You do not have to state whether it is nucleophilic or electrophilic. However, if you stated it was nucleophilic, you'd be correct. If it's one nucleophile or another nucleophile. Okay, so that was the how to make an acyl chloride. You make them from carboxylic acids and you use one of those weird reagents, SOCl2, PCl3, or PCl5. Now, we are going to the general reactions of acyl chlorides. Yes, Acyl.
On the test, are they gonna ask us whether it's nucleophilic or electrophilic?
If they ask you for the mechanism, typically. General reactions of acyl chlorides are generally nucleophilic substitutions, but can sometimes be called hydrolysis if you're using water. So they're all grouped together here because they're all kind of the same reaction, and I'm going to show you some examples. So let's say that we had CH3, COCl plus, and let's say that we put this with alcohol, HO, CH2, CH3. I don't know why I wrote like that, but okay. How would this reaction proceed? The same way that esterification proceeds, except instead of taking out H and OH, you always take out H and Cl from all of the acyl chloride reactions. So wherever the OH would have been taken out, you're taking out a chlorine instead. So that means that in this reaction between this alcohol and this acyl chloride, you take the chlorine out from the acyl chloride and you take the hydrogen away from the electronegative group. So you're taking out H and Cl. What would that make our products?
CH3, CO, OCH2, CH3.
Yes. And you form an ester. So another way to form an ester here.
This is like
So-
the condensation one.
Yep. Let's try another one. Because like I said, all of these, actually acyl chlorides always do the same thing. You take a Cl out from the acyl chloride and then you take an H out from whatever the other group you're reacting it with is. The other groups can be carboxylic acids, alcohols, water, base. Like it can be so many different things. And all the different things it could be in are here. It could be alcohol, phenol, ammonia, amines, water. Like all of these things do the same thing with an acyl chloride. So let's take a look at another one because it's all the same type of reaction. CH3, CO, Cl plus water. What would our product be? What do we take out? Take out the Cl from the acyl chloride and an H from the other molecule. So you take these two parts out, right? And then you smush the rest together. That's why I said these reactions are very similar to what we saw in Unit 5 when we were putting together monomers to form polymers, condensation polymers. And actually, acyl chlorides do condensation polymerization the same way. So this would be CH3, CO, what comes after? OH plus HCl. Yes,
Chloride and methanoic acid.
yes. Yes, this would work to make methanoic acid. That's why I said you could start with an acyl chloride and make methanoic acid. CH3, COCl plus. We said this could happen with phenol. So how would that look? What would we take out? The Cl from here and the H from the phenol, not the H from the benzene. So then our product would be
CH3, CO, O, that's good.
I would do it like this. Yes. Plus HCl. And we can't forget amines. This also does these reactions with marriage amines. So CH3, COCl plus NH2, CH2, CH3. What happens this time? What would we make as a product?
They got the H and N too.
Oh, that might.
Take out H, take out chlorine, yes. And you make CH3, CO, and yes, you make an amide, you're right. NH, and then CH2, CH3. And you make an amide, plus HCl. So acyl chlorides can be used to synthesize esters, to synthesize carboxylic acids, to synthesize esters on benzene rings, to synthesize amines. They could be used to synthesize all sorts of things. So that's why I said all 5 of these reactions are extremely similar to each other. You just have to know if you're working with an acyl chloride, if you're taking the chlorine out from the acyl chloride and you're taking out an H from whatever's next to the electronegative atom on whatever other molecule you're combining it with. This one with water, you can call hydrolysis because you're using water to break up the acyl chloride. The other ones, you call them substitutions.
Yes.
Yes.
Well, what are they kind of used? in the pool.
Oh, so this is not even mentioned by Cambridge, but I believe this is a pyrimidine. No, you don't have to write it. It's just from an image I found online. They do not expect you to know that, but that would be a solvent of pyrimidine. Organic solvent. Hydrolysis of acyl chlorides. Okay, so there is an ease of hydrolysis that Cambridge wants you to know the order. So what's the easiest to hydrolyze to what's the hardest to hydrolyze? Easiest to hydrolyze and the most difficult to hydrolyze. Acyl chlorides are the easiest to hydrolyze, meaning they react the easiest. So you should write down what the structure of that is because it helps to explain why.
You need to explain.
Yes. Guess what's coming? Explain why. Right? Chloroalkane. CH3, CH2, CH2, Cl. And then aryl chloride means this. Most difficult to hydrolyze. So what that indicates is that this chlorine is the easiest to come off, and this chlorine is the most difficult to be released. This one will not be released. So we have to think about why would that be. Anybody have a guess? Isa.
Okay, maybe it has to be. I mean, it has to go with polarity.
So for this, you've got C double bond O being an electron
Okay.
withdrawing group. So electron withdrawing group weakens the CCl bond. So that makes sense. So what's going on with chloroalkane? Why would that be harder to hydrolyze? Why is the essential thing is why is it more difficult than the sport? Because these are donating, yeah, the inductive effect. So inductive effect strengthens the bond. Because you've got EDGs next door, electron donating group, strengthens the CCl bond. That's going to make it less likely to break. This one's interesting. What's going on with the arrowbenzene? Caesar. What's an electron donating group? Yes. And what does that mean?
That depends that the chlorine will donate like
So what that means, if it's donating into the ring, is that this bond is actually being strengthened by these electrons being donated into the ring. And these electrons being donated in help form the resonance with the like the ring electrons, the pi electrons. So it becomes part of the pi bonding delocalized system. You're right, Caesar, absolutely. So
Acyl.
it is. Go back to lesson 2. All of the halogens are electron donating groups because of their unshared pair of electrons. They donate into the ring. Just like alcohols, that unshared pair of electrons from OH donates into the ring. Same thing with ethers, it donates into the ring. So that's actually absolutely correct. And the idea that I had said is that the lone pair of electrons from Cl forms part of the localized pi bonding system. So basically goes and joins with the ring electrons and forms part of the resonance structure, the pi bonding system of electrons. And so that's the concept of what Cambridge wants you to know. Lone pair of electrons from the chlorine forms part of the delocalized pi bonding system. So the delocalized electrons that are part of the ring, the 2 electrons from the chlorine join into there, which strengthens the bond. And because the bond is strengthened, then that chlorine is not reactive as a result. Anytime the bond is strengthened, it's less reactive. Anytime the bond is weakened, it's more reactive. It's the concept to know about how to explain all of these questions actually with acidity, basicity, hydrolysis. It's really the same type of questions over and over again. And so what we're going to see now is a paper 4 question. I'm pausing till most people are done writing. Yes. Strengthened, it's less reactive. And if the bond is weakened, it's more reactive. Ashley and Danny, when you came in late, did you get scans for tardy in the front? Okay. Just making sure. Ready to continue?
Wait, Missy, is that a pie right there? The light bulb?
Yes.
Okay.
Where?
Well,
Oh,
there's also one on the door.
no way.
I had 25.
There was one on the outside of the door. That one was particularly.
Yeah, like whenever you
Yeah,
open the
yeah.
door, there was like
Yeah.
one behind. Like,
Yeah, I saw all
I
those
love
pies.
the idea. Though. I thought that was a fun scavenger.
Yeah,
Fine.
Daniel, I saw all those pies on like
Okay.
Friday, you know?
All right, let's try a question.
Yeah, I did.
Benzoyl chloride, chlorobenzene, and chloroethane differ in their rates of hydrolysis when each compound is added separately to water. What is the ease of hydrolysis from hardest to most to easiest to hydrolyze? And then explain. So, which of these three is the most difficult to hydrolyze? Chlorobenzene.
I'm actually dyslexic.
The easiest would be benzoyl chloride. And the one in the middle is chloroethane. So it's 1 mark for getting the correct order. Go ahead. There's 1 mark for saying that the order is related to how weak the CCl bond is. There's 1 mark for saying that the order that you came up with is linked to the fact that the weakest bond will be the easiest to hydrolyze and the strongest bond will be the most difficult to hydrolyze. And so then the other mark, you could say any one of these 3 things. So this was 1, this was 1, and then they gave you 3 options that you could say for the last mark. So there's multiple ways you could go with it. If you had said that benzoyl chloride has a C double bond O electron withdrawing group, that's the mark. Because that weakens the bond, making it the most reactive. You could have said that chloroethane has a positive inductive effect, which strengthens the bond. Or you could have said that in chlorobenzene, the electrons from chlorine are delocalized into the ring. Into the ring. So any one of these 3 things. You did not have to say all 3. Any one is a mark, is the way that they awarded it. If you had said one of those 3 things. You could obviously say more. If it was worth more marks, like let's say this was a 4-mark question, you would have had to say 2 out of 3 of those things. So that's how they could adjust the marks here. You all ready for a mechanism? I know you are, right? You gotta be ready for a mechanism. It's our second mechanism. 2 out of 2 for the units. That means there's only 2. Electrophilic substitution, and today is addition elimination.
Hey, do we still need to remember like the ones from yes?
There is a non-zero chance they can show up. I've even seen free radical substitution on a paper 4. That's the thing about paper 4, anything can show. It's just like 80-20, like 80% of the marks are from A level 10. All right, so addition elimination mechanism for the hydrolysis of acyl chlorides. So the question is, how does this happen? How do we go from here to here? Remember, when we have a mechanism, it tells us what exact bonds are broken and what new bonds are formed. And so I have one that's up here already pre-done for you, and then we'll create one from scratch. So the first thing is to write your dipoles. On your acyl chloride, you would need to write your dipole. So mark 1 would be to write dipole on the acyl chloride. I hope it makes sense that carbon would be partially positive and oxygen would be partially negative, because carbon is less electronegative and oxygen is more electronegative. So you write a dipole on your acyl chloride. Typically part of the same mark, but I'll write it as a possible mark too. But usually they are part of the same mark, is to have your nucleophile come in, the pair of electrons on nucleophile form a bond with the carbon. The thing is, you cannot leave it like that, because if you did, you would say that carbon had 5 bonds, and carbon does not have 5 bonds. So within the same step, you are immediately supposed to show that the pi bond of the double bond, the second bond of the double bond, breaks. And you get this. The 2 electrons go from the double bond to the oxygen. That would be part of the same mark. Mark 3 is a correct intermediate. This right here is the intermediate. Oh, sorry. There's 2 intermediates. This right here is your intermediate 1. Once you've got your first intermediate, what happens is the double bond is restored. So you see that here. And then one of the bonds has to break, because carbon cannot have 5 bonds. And so the bond that breaks is the easiest one to break. And the easiest bond to break is the weakest bond. And the weakest bond would be the one between carbon and Cl. The reason we use acyl chlorides in the first place is because they're so easy to react. And so this bond, so when this comes over, this bond would break. And so that would be your possible mark 4. So mark 4 is the lone pair from oxygen, reforms double bond, and CCl breaks. That's your mark 4. And so then you have this result, right? Once that happens. And you've got water with oxygen with a positive charge, and that doesn't make any sense. And so your final mark here, so this is a pretty long mechanism. Mark 5 is to have your nucleophile. Here it's Cl minus. Grab an H from the water. And bond to the oxygen. Like that. So there's a lot going on in this mechanism, but I'm going to show it from scratch. This is one that was already, welcome back, pre-done for you. But we'll take a look at one from scratch. Which is going to be checkup 5. And then after we do the mechanism, it's just practice questions for the rest of class. We've seen most of the standards after the mechanism, and it's just practice reactions after that. So once again, this is the second of the 2 mechanisms. This one shows up less often, but it could show up on your paper 4. The one that usually shows up is electrophilic substitution. Yes.
Why does the C double bond, I mean, wouldn't the double bond of the oxygen be weaker than I mean, it's a pi bond versus a sigma bond, so.
But the acyl is more reactive, so it goes back. And remember, this is proposed. We know this happens. This is the proposal of how this happens. This is a theory of how this happens. All right, so this we actually already answered because I put a Cambridge question already for this. Let's go straight to the mechanism. write the mechanism of the hydrolysis of propanoyl chloride with water. So let's see if we can trace out the steps and see how we can get from our reactants to our product. So propanoyl chloride with water. CH3, CH2, COCl plus HOH. So what would happen first? What do we need to do first to show how this happens? Because remember, we know the end product is we're getting a carboxylic acid plus HCl. But how do we get there? That's what the mechanism is. Where would we start? You need a partial positive charge here and a partial negative charge here. Because the idea is that nucleophiles are attracted to electrophiles. So you need to show on your oil chloride what's positive and what's negative. Because what has to happen is 2 electrons from your water are going to go bond with that carbon. But you cannot keep this with 5 bonds. Nobody will allow you to keep a proposal that keeps it with 5 bonds. And so you need to break one of these bonds. And the bond that's suggested is the pi bond. And if you study future organic chemistry, you're going to see that this actually happens a lot with almost all biochemical reactions. They break the pi bond and then it reforms. CH3, CH2, CO minus, Cl, and then OH like this, plus. That's your intermediate. Technically, it's intermediate 1. What happens next? Everything right now is linked onto this molecule.
Mine's like plus.
Because of its formal charge. Because it has 5 electrons it has ownership of, and it's supposed to have 6. 6 minus 5 is +1.
Okay.
Yeah, so if you have O like this, -2. If you have O like this, it's -1, right? If you have O like this, it's charged at 0. So if you have O like that, it's +1. Yes? Does that make sense? It's because of formal charge. Formal charge. Which Cambridge, like I said, they don't teach that. But I taught in the first lesson of this unit because I think it's helpful to your understanding of what's going on. That's why it's a +1 charge. Yes? So now what? So now this double bond reforms, but carbon cannot keep 5 bonds. So one of these bonds has to break.
Yeah.
And it's the chlorine because it hydrolyzes the easiest. It's the weakest bond. It's the one that breaks off. And so you end up with CH3, CH2, C double bond O, OHH. Gross. Let's see, minus. That's intermediate 2, right? Intermediate 2. So now what happens? Technically, this is really gross. You cannot stay like this because oxygen should not under any means have a positive charge. So this can only last for a very short period of time. And so what happens to restore what's normal? This pair of electrons is going to grab that hydrogen to make HCl, which is one of the products. And then these 2 electrons, because hydrogen cannot both be bonded to chlorine and oxygen, the 2 electrons that were bonded to the alcohol, like that. And so our final product would be CH3, CH2, COOH, and HCl, right? So this is the reaction of hydrolysis. We call it the addition elimination mechanism because you first add in a group and then you eliminate another. The chlorine is the one being eliminated. Okay, guess what? You get to try one yourself. course, you get to try one yourself. On the next slide, it says your turn. So I want you to try the mechanism of ethanol chloride. ECOCl, right? Ethanol chloride with what? Ethylamine. So just to help you out a little bit, how should I face the amine?
To the thing.
I should face the NH towards the chlorine, right? To see what's going on there. And so then this would be CH2, CH3. All right, try this yourself.
Yes, try yourself.
I'm going to give you 5 minutes. Oh, and that's going to have to end it today, I guess. Yeah. And that's going to be the last thing before we go in our group. So
We had so many points.
we'll have to add them to next class. I don't think I put this on next class committee assessment anyway. All right, so I'm looking for your mechanisms for a stamp. And then when the timer's up, get into your groups. Yeah. You can take a picture of it. While I'm waiting, I'm going to give you the mini assessment practice for next class so you can see what that's going to look like. I'll put up an answer key tomorrow. Here you go. And remember, the mini assessment itself is a grade.
Zach, you're so annoying. You're actually annoying. Huh? What? What do you say? What? What?
That's what you're doing on your own if you want to study for the mini assessment.
Okay.
That's next class.
Wait. Where is this like? Where is this like going thing?
Yes, it's a man.
Oh my god, just bringing back flashbacks. Like, no.
I'm going on this.
Hold on. Let me come to raised hands. You're missing, you're missing this or the lone pair, because the lone pair is there in there.
Did you raise?
You're welcome. 2 minutes to try this yourself. And then I want you to get your groups, your C groups, your 7 groups. Come up with your name if you don't have it. And remember, we're going to start at 8:55.
There already no reaction.
Yes, there can be no reaction.
Okay.
This is so wrong. Wait, it is right. This is so wrong. I don't even know what I'm doing. Okay,
Yes. Right.
I think Dana hit back and all.
Dude, you're actually annoying.
What are you doing?
Oh.
Huh?
You haven't yet, but like the mechanism is like the
It is, yeah.
I don't even know what I'm doing, man.
Hold on.
Ready for you?
What do you say?
It is to use one. Hashtag one.
This is
Why?
because this are like 5 hours per summer.
Ugh. Okay, so my question is, I'm still struggling with how the bio curriculum lines up with natural science full biology questions.
Oh, I think I know what we're gonna do.
Like, I was looking at the bio last night, and I'm like, it does not seem like it correlates.
Well, the how many have you done now?
Yeah. It would have helped.
Has that? This one. This is American last one. What?
This one.
Why?
It's because the American Bio, the Cambridge Bio doesn't seem to like, but the Cambridge I think does, the chemistry. I think it correlates.
The group.
Because I did all the problems with Cambridge questions versus, but I also taught that good stuff.
Yeah.
Which I know isn't happening with bio. So bio's gonna be our weak link.
Oh,
Unless somebody goes study it over the summer.
like see, isn't like CH3 like yeah, the conversation is probably the best.
Strategy. All right, at this time, go into your groups, get into your teams.
What is the real one? What is the real one? Wait, is this? Oh.
Get into your teams at this time. Go one table, one device. One table, one device.
Guys, come over here.
And I'm looking for your names. You will use your names for the Kahoot. Your team name. So join at one table with your members. 3 broken away.
We can use all of
Flashcards away. All of it. Put it away.
We've been talking about
Okay.
we do this together. Like,
Well, you can study for 7 minutes with your group.
you know the NO2 thing? Wait, then change. No, it's on. It was like doing the script.
Again?
I'm trying to find it, but
Oh, is Glenn a replacement for Matthew?
Yeah, Glenn.
okay, can you see this?
You'll want a device that you can see the Kahoot with. Because things show up on the screen that you may not be able to see. So you want to make sure you're in Google Meet.
It was like different. This one.
Right?
My goodness, see this? Is it real?
Okay. Yeah.
Like, is it real? It's like different. This
I should also like point out that Glenn is gonna have a higher score than the video assessment.
Daniel, you know, like, Daniel, don't worry. You'll eventually get one of the Three Musketeer titles when, like, what's it called? When the official sequel to the Three Musketeers comes out. Oh, the other official sequel.
It did.
No, the sequel to the sequel.
It also did.
Sequel to the sequel to the sequel.
Also,
Sequel to the sequel to the sequel to the
that's
sequel.
where it ends. No, I think I'll.
Yeah.
Like I showed how to get it here.
Yeah, I have
Right.
that.
I showed how to do this. So if it's wrong in there. It's the right one.
No, like when it, the Three Musketeers, Electric Boogaloo comes out.
Electric.
Yeah.
What does that mean, Ramon?
Three Musketeers, Electric Boogaloo.
Okay.
One device per group, and you should be logged into Google Meet to see the screen, just in case you can't see the screen from where you're sitting. Code is 72448. Wherever you're entering with your group's name, you can get whiteboards to help you out, but there's only 30 seconds a question.
No, they just signed.
Yep.
You have two?
Probably. Yep, 30 seconds per question. Okay.
Stop. Daniel. Your name is Daniel.
I know that, Ramon. The counterback.
You like math.
Axel?
Thank you.
10 years after.
Zach, it's still.
All right, Daniela.
10 years.
Isabella Flores, what is your team
Hey.
name?
Guys, what is it?
Sarah Caraballo,
8, 6, 7.
Victoria Alvarez. What are we?
Relax. If you can beat our team.
No, this is the middle of the meeting.
Are we the leader, right?
8, 6, 7.
I am.
Okay. The sweet week.
I accidentally. Okay, let me just.
Shahada, Jaden, Omar, Alexander, I've got your name. You're the Super 17th, right? That's what you're putting in. All right. Ashley, Danny, Thomas, Analia, what's our name? Are you the formal?
No, not that. That's good. You get us mid.
All right. Francesca.
There we go. Yeah. I like tried to understand it. Like once I've had like whole week of
All right. Seven, Isaac, Jose, and Casey. What are we?
Team 6-7.
Team 7 is team 1, right?
Who are you guys?
6-7. Team 6-7. So much.
Yes.
I mean, it's not common to answer, right?
Actually, you know, give me 6-7 plus my no.
It's like if really, then I'll get a brain freeze.
You named yourself.
Yeah, brain freeze.
Nice.
3 minutes. Are y'all locked in?
I'm kidding.
Are you all locked in?
Daniel, you can't talk. You were like, you literally named what's it called alumni.
Team 7.
I know, but like you make jokes about like
Team 1.
Oh!
Team 1 is the sweet
Yeah.
sweets.
I did not realize it. Actually,
The sweet sweets are team 1.
It was like a combination of things,
Oh.
Team 1.
Yeah, so it's like I keep saying, you can't be talking, okay?
Sometimes it clicks by itself.
That team right there is team 1.
They're like gators.
They're team
Also, just
7.
saying random German words all the time. Well,
I mean, it's set up there.
yeah.
It said it. So team 1 is the sweet sweets.
Application derivative.
Team 4 is the formal. Team 5 is the phenol stems. Team 6 is team 6-7. And team 7 is team 1. That's not confusing.
Do you not realize that?
Are you all ready for Hungry Games? Them? They're the sweet sweets. Notes away. Flashcards away. Workbooks
No,
away.
that's not how you say it. You're saying it's
Everything away.
Nasty.
Only brain.
kind of.
30 seconds or less per question.
Why are you saying
You asked me. Congratulations. Are you doing? That's what I was doing.
it's on?
Yeah.
Perfectly saying it, yes.
Careful.
Poor Jose.
Yeah, yeah.
I mean, there's a lot of people that came before that would say that. A lot of the last year and year before, seniors. All right.
You know, UF is probably like maybe better.
There's a workbook that needs to be put away over
Why is it
here.
in Chinese?
There's many assessment practices that need to be put away.
I don't want to go over stuff.
Right, that was- Yeah. Listen,
Game is
Listen,
starting
I
in
just
30
listened to
seconds.
right, Daniel?
30 seconds. Remember to be logged into Google Meet in case the screen is small. For any questions. Google Meet. Google Meet.
Oh, right.
Oh, yes.
All phones away except for your one device. Game starts in 5, 4.
Super 17.
I can't make it as a
Yes, as long as I walk through and see the only ones on Google.
It's too stressful. It's too
Are
stressful.
you
It's Team 6-7.
You gotta go.
Okay, that's fine.
Yeah, make sure to turn the
Five.
microphone.
4, 3,
Going now.
2. Write that off your board. 1. Start.
Green.
Right here.
Maybe this one.